Hello there, in this video we're going to be solving the following problem. A rock is dropped into a lake, creating a circular ripple that travels outward at a speed of 60 centimeters a second. Now find the rate at which the area within the circle is increasing after just 3 seconds, or at the 3-second mark. So the first thing I want to do here is label the data we're given. So we're given that the ripple is traveling outward at a speed of 60 centimeters a second. So this part is very important. And we want to find the rate at which the area within the circle is increasing. So it's going to be some kind of rate of area for a circle, which means we're going to be wanting to use the formula for a circle, because when you're dealing with derivatives and you want to solve this type of problem, you normally want to find the formula for what you're trying to find. In this case, it's going to be the rate of the area, the change in area for a circle. And the area of a circle, if you remember, the area of a circle is equal to pi r squared. So pi r and squared. And what we're looking for in this problem is specifically the derivative of the area change in terms of time. And this is what we're looking for. But we're actually given this 60 centimeters a second for the speed of the circular ripple. That's actually the change in the radius, because the radius is going to be increasing at a rate of 60 centimeters a second, because that's the rate at which the ripple is moving outward. The circle is expanding. So we have the rate of the radius, its change over time, or in terms of time, that's going to be equal to 60 centimeters a second, you could say. So now this is all the information we're given. So then the next step we're going to be taking is finding the derivative of everything inside this formula. So the derivative of the area in terms of time is going to be equal to then pi. Then we're going to have 2r if we take the derivative of r squared. So we have 2r here. And because we're taking the derivative of a value we don't exactly know for r, we have to add in the dr dt here. So we have dr and dt. Now the next thing we want to do is solve for dA over dt, because that's what we want in the question. So we do know the value of dr and dt. It's right over here. It's 60 centimeters a second. Therefore we just plug that in, and we can get dA over dt equaling pi 2 r, and then the rate. Well, actually, if we go back, what is the r value? Because we know that the dr dt value is 60 centimeters a second. Well, what's the radius at 3 seconds? Well, we know that the rate is 60 centimeters a second, correct? And we want to know what it is at particularly 3 seconds. That's just going to be 180 centimeters. So now that we know that, we can plug the 180 centimeters in as the value for r at that one instant at 30 or at 3 seconds. So we plug it in, 180, and then we plug in the value for dr dt, which we got as 60, and then we just solve this out to get our final answer. And if you were to do the calculation, you would get something around 21,600 multiply pi. Just to keep it simple, I won't multiply pi throughout. And that is the final answer. If you want to format it properly, this would technically be centimeters squared per second. It's a rate. That is the rate at which the area was increasing after 3 seconds. Thank you for watching this video. If you have any questions, feel free to ask in the comment section below, and I will do my best to answer your question. And I do hope you're having a fantastic day.